Welcome to PreMath. In this video, we have got this red square along with this right triangle AED, as you can see in this diagram, such that this EF is the perpendicular and this side length AE is 9 units. And now we are going to calculate the area of this green shaded triangle BPF. Please don't forget to give a thumbs up and subscribe. Let me make it very clear that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's the very first thing we are going to do. Let's focus on this square ABCD. Let me go ahead and label its side length. Let me call this side length B, since it has all equal sides. So this side is going to be B, this side is going to be B, and this side is B as well. And moreover, since we are dealing with these rectangles, so therefore if this side is B, then this side is going to be B as well. And here's our next step. Let's focus on this green triangle. And we know that this angle FPB is a right angle, since we are dealing with these rectangles. And now let's go ahead and calculate the area of this green shaded triangle. And now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, the base of this green triangle is B. And let me call the height of this triangle this BP as H. Then the area of this green triangle is going to become a half times base B times height H. Let me call this as our equation number 1. And now our task is to find the value of B and H in order to calculate the area of this green triangle. And now let's focus on this rectangle ABPF. And we know that these two side length BP and AF are equal in length. If this side length is H, then this side length has got to be H as well. And here's our next step. Let's focus on this big right triangle AED. And now let's assume that alpha and beta are our two complementary angles. In other words, sum of these two angles, alpha plus beta, must be equal to 90 degrees. So therefore, let me label this angle as alpha. And since this is a 90-degree angle, then this angle has got to be beta, since alpha and beta are complementary angles. And now let's focus on this right triangle EFA. And we know that this angle is alpha. This is our 90 degrees angle. So therefore, this angle has got to be beta. So therefore, we conclude that this triangle EFA and this triangle AED are our similar triangles according to angle-angle similarity theorem. Now let me go ahead and label this side ED as X and this EA as Y. Then we can see we are going to have a proportion. In other words, let me go ahead and look at this thing. Side opposite to this 90-degree angle is Y. And the side opposite to this angle beta is H. So let me go ahead and write down Y divided by H equals to, let's focus on this bigger right triangle AED. The opposite side to this 90 degrees is this whole length B. Let me go ahead and write down B divided by, and the side opposite to this angle beta is going to be Y. So therefore I can write Y at the denominator. And now let's go ahead and cross multiply. So therefore we are going to get B times H equal to Y square. Y times Y is going to give us Y square. But we know our Y value is 9 units. So therefore I'm going to replace this Y by 9. So therefore our B times H value turns out to be 9 square, or simply B times H equals to 81 1. And here's our final step. Let's go ahead and calculate the area of this green triangle. And we know that our area of a green triangle equals to a half times BH from this equation 1. And here I have copied it down. But we already figured out B times H value is 81. So I'm going to replace that one over here. So therefore the area of this green shaded triangle is going to be a half times 81. And if we simplify this thing, that is going to give us 40.5 square units. So thus the area of this green shaded triangle turns out to be 40.5 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.